Hello, good afternoon, everyone. I'm Anikshik from the team Sleepy Nerds, and I'm here to perform the ninth in tech ninth track, which is for the basically the problem statement is for smart contain risk engine. What it probably does is global trade moves millions of containers daily, but customs officers only have seconds to decide is the shipment safe or not, or is it a risk factor or not? Does it have high risk factor or not? We first of all we will train the historical data that was given to us, which has more than 54,000 around historical records to identify the 1% of critical threats without slowing down the legitimate rate. So today, I will be showing you how we achieved 99.4% critical recall using a 25 feature advisable adversarial model. So first of all, we could see the overall accuracy of the macro F1 related to the training data set directly. So how does it actually count? How does it actually decide the risk factors? We will use this real-time data that was given to us. And first of all, it is divided into different parts, and total 25 features are listed into it. So basically, first would be the physical anomalies that would be like measured or declared weight and uh, things like that. The weighted different uh, packet and weight discrepancy, weight flag, binary tag, and then there would be economic adversarial, the tax evasion layer. That means the unit values at score and Benford div and many other. There's a reason as well written here. So like import has a prior violation history 100% rate that every time it has sent something, it was flagged very critical. So it would be now as well. It depends on the historical data of the importer and exporter as well. If there's an issue, it will flag it critical to just to check it. Then there's a behavioral logistic which calculates the z score, log dwell time, and root risk. If the root and also it for the next one it also checks for the time limit if it is in between the 10 p.m. and 6 a.m. factor. Was it a weekend, night high value goods declared in the middle of the night or something like that? Weekend nights as well. Then the last one was the anomaly score and importer risk or exporter risk, the dynamic one. So here, if you could see, there's a low risk for this one because the exporter historical history risk was low and it has a 43 percentage of score, and hence it was not flagged critical. Even though having a 44 score, it was flagged critical because of the reason weight anomaly flag is low. Importer has prior violation history of 25% rate. So it's better, like precautions are better than cure. So basically like that. And also we can download these particular CSVs. Also the accuracy for our particular model for that for this real-time data is around 1% critical ratio and the 25 training data, my bad. And the alert is- accuracy is the 76.9, and the overall accuracy macro F1 depends on the 90.3% target. It actually goes here and there a little. We can download the report and also check it exactly like what's the issue. And also here you could see the report like there are 25 features engineered. Critical loss ratio is 1.01%, 90.33% outstanding. The overall accuracy of micro one recall is 85.32%, and 94.2% is the separation power. Now this is it, and also we could see these uh, CSUs as well. So basically it has all the data why it was flagged normal, low risk, or high factor critical, right? And first of all, what we did was we calculated it on the SPS modeler specifically and checked it out like how particular things would work from our end, and then we constructed the backend. So this was the analysis of our model. And the coincidence matrix was about for the clear one, being clear was 42, 42,042, and it flagged lowest for 5 and critical 0 as and critical was 5,420, which also like 10 or 20 plus minus was done. And we got the 99.87 correctness accuracy here, and the clear and critical performance evaluation, we could also see it. And these are the table. I will just show you here. So these are this is what we got this from our analysis, and yeah, that's it. Uh, thank you. Also, we used XBoost, XGBoost with SMOTE. So to handle the 1% class imbalance, optimizing specifically for micro F1. And yeah, that's it. Thank you so much.